Hello everyone, welcome back to this video series on clinical trials programming. In this video, we will see what is the dataset size specification limit specified in FDA's Study Data Technical Conformance Guide. So if we go through the section 3.32, so this is the file that I am referring is 2023 December file. So the version of FDA Study Data Technical Conformance Guide, which was released in December 2023, is being referred in this video. So according to this version of the SDTCG, so we also call this Technical Conformance Guide as SDTCG in abbreviated form. So, so as per this document, so we have to submit each dataset in the form of a single transport file. Let's say we are submitting our LB data, so we have to submit it in the form of export file, which we have the extension of .xpt. And it says the maximum size of an individual dataset that FDA can process depends on many factors, and datasets greater than 5 gigabytes GB in size should be split into smaller datasets no longer than 5 GB. So the highest allowed size as per this version of SDTM IG for a single XPT file is 5 GB, and if it is greater than 5 GB, so we'll have to split it into equal number of datasets so that each split dataset is no longer than 15 GB. Let's say if you have your XPT file which is going into 15 greater than 15 GB, let's say 16 GB. So you will have to split it into four parts so that each individual piece will be like less than 5, less than 5, less than 5, or your the let's say if you are able to split it into exact 5 GB, you would end up having the final split dataset of exact 1 GB. So, and we do not go by the size of this dataset, we'll have to use a logical split. We'll see that in a while. What do we mean by a logical split? So, sponsors should submit these smaller datasets in addition to the larger non-split datasets. So though we are splitting our single dataset into multiple datasets, it is clearly stating that we need to submit the split dataset and also the larger non-split dataset. So to better support regulatory reviewers, the split dataset should be placed in a separate subfolder, subdirectory labeled split, and a clear explanation regarding how these datasets were split needs to be presented within the relevant data RG. Let's say if we are splitting our SDTM-LB dataset, we'll have to explain how the algorithm that we have used to split the dataset in CSDRG. So let's say if we are splitting our ADLB, which is an analysis Adam dataset, so we'll have to explain the logic on how we have split the ADLB dataset in our ADRG. So that's why it is using the term of within the relevant data RG. RG stands for Reviewer's Guide. So now let us quickly take a look at the folder structure because they are talking about. So the split datasets have to be clearly placed in the directory called split. So the dataset submitted to US FDA are to be placed in a standard folder structure. So if we take a look at here, we have a folder for datasets in which there can be within a submission we can have one or more studies. So we will have a folder for that specific study, and within which we have datasets which are used for analysis and also tabulation. So analysis datasets, we have a subfolder for Adam. So where we have a dataset folder called datasets to place our XPT files of Adam dataset. So if we are splitting some datasets, the split datasets will be put in this subfolder called split, and the parent dataset would be put in this datasets folder. Similarly, under tabulations also, if we see, so we have our SDTM, and within which we have our split dataset. So if we are splitting our LB into, say for example, LB1, LB2, LB3 and so on, so we'll have to put that sub split datasets into split folder and the parent LBXPT into the SDTM folder. So now let us see an example wherein it was described in again the SDTCG Technical Conformance Guide of US FDA. So it says the size of LB domain datasets submitted by the sponsors is often too large to process. So this issue can be addressed by splitting large LB dataset into smaller datasets according to LB-CAT and LB-SCAT. So here they have given an example on how you can split your dataset. So they are asking us to consider the values in LB-CAT and LB-SCAT values. So to split. So using LB-CAT for initial splitting. So what does this mean? So if let's say the LB-CAT possible values are like your hematology, chemistry, and urinalysis. So we'll have to first try to split the dataset based on the values present in LB-CAT. So if the size of those individual split datasets is still greater than 5 GB, so we'll have to use the subcategories within each of those for the subsequent splits. So that is what is mentioned here. If the size is still too large, then use LBS-CAT for further splitting. For example, use the dataset name LB1 for chemistry and dataset name LB2 for hematology and dataset name LB3 for urinalysis. Splitting the dataset in other ways, say for example by subject or file size, makes the data less usable. So what is the advantage of splitting using the values present in LB-CAT is, so most often we generate reports separately for the each individual categories like hematology. So we may summarize the lab data for hematology and then we may summarize the lab data for chemistry separately and similarly for urinalysis. So if we split it this way, all data of all subjects of hematology would be present in the same subset. Say for example, if we have 200 subjects and if we are splitting the dataset based on 100 first 100 subjects in first dataset and second 100 subjects in a second subset. So what would happen is if they want to analyze a particular category's values, the data for first 100 subjects of that category is present in a separate dataset and the second 100 subjects is present in a second dataset. So this is not immediately usable. So that's why they are asking us to logically split based on the values of category and subcategory. So sponsors should submit the split files in separate folders or directory, which is clearly documented in addition to the non-split standard LB file in the SDTM directory. So which is what we have seen in the previous screenshot. So hope this is helpful. Thank you for watching and keep learning.